So if the formula says cos 2 theta, that means we're using the double angle formula. So we pick one of the equations. But first we need to create a triangle. 90% of the time, that's what you need to do to start. So they tell us that cotan is 8 over 15 in quadrant 1. Yes, I'm a teacher, James. So this is quadrant 1. If tan, TOA, is opposite over adjacent, then cotan is adjacent over opposite. So we set up the triangle. You can do Pythagorean theorem to find the last side. Then from there, you just plug in. So remember, when you're plugging in right here, when it says cos theta squared, you're saying, when you say cos theta, you're saying what's the ratio. So given this angle, if cos, so ca, if cos is adjacent over hypotenuse, then adjacent is 8, hypotenuse is 17, so you plug that in right here. You then square it. So 8 times 8, or 8 squared is 64. 17 squared is 289. You then multiply that value by 2. You subtract it from 1, create common denominator, and you get negative 161 over 289. For the second problem, we're still going to refer to the triangle above. Now, this one, we're using the half angle formula. Now, obviously, there's no formula that directly says cosecant theta over 2 equals, but we need to work with reciprocals. We always want to work with sine, cosine, or tan. So there is a formula for sine of theta over 2. So we follow that formula, and cos of theta, we're looking at the triangle above, and again, cos, so ca. We look at the ratio adjacent over hypotenuse. We plug that into the cos theta spot. We simplify under the radical, and we end up getting square root of 9, which turns to 3 over square root of 34. Now, before we think about rationalizing the denominator, right away, we're not finding sine of theta over 2. We want the cosecant. So once we find the sine theta over 2, before we simplify, we can just flip that fraction, and cosecant of theta over 2 is root 34 over 3. Because we're in quadrant 1, that's where our triangle is, that's where our terminal side is, we know that the value cannot be negative because all values sine, cosine, tan, and their reciprocals are positive in quadrant 1. That's why we don't say plus and minus, we cross off the negative. Okay, to start off number 3, they tell us that sine of this angle, you can call this theta, x, any Greek symbol. They give us the ratio. We know sine's opposite of our hypotenuse. And we know that the angle has to be between 270 degrees and 360, or 3 pi over 2 and 2 pi. Therefore, if this is 270 degrees, or 3 pi over 2, and this is 360, or 2 pi, the triangle has to be in quadrant 4. So when we draw it, we know to the right is positive, so we know it's positive 7. We know down is negative, so we know the negative is with the opposite side. And we know the hypotenuse is positive, and it's 25. We can find all sides using the Pythagorean theorem. So once you set up what they give you, if you're trying to find half angle tan, you use this formula. And when it says cos of, you're just using a Greek symbol for an angle, you know cos is adjacent over hypotenuse. So you're looking at the triangle to figure out what the fraction is going to be. And then you plug in. So it's 1 minus the cos of that angle is 7 over 25, all over the sine of that angle, opposite of our hypotenuse. When you simplify, you get negative 3/4. Okay, then for secant of double angle, right? This you could say is secant 2 theta. You first, you need to always work with sine, cosine, or tan, and then you can flip the final answer if you're dealing with a reciprocal of one of those. So the reciprocal of secant is cos, right? COS ends on S. Secant starts with S. So we're first going to work with cos double angle. So cos 2 theta is equal to this. You can pick one of the formulas. If you use the triangle above, we know that cos of theta, or cos of that angle, is adjacent over hypotenuse, 7/25, but then you square it because it's cos squared. Order of operations, once you do 7/25 squared, you then multiply that by 2, you get that value and then subtract 1. You get 527/625, but then because it's secant, you have to flip that value. And because your triangle was in the 4th quadrant, and all students take calc, we know that only cosine and secant are positive here.